We just have
Hey,
to prove
this
that
is
this
Wendy
angle here,
Kalishwayo.
which
Can
is
you
angle
please
A1,
help me
is
with
equal
question
to angle
11
A1.
here?
But if you look at what we are looking at, angle A1, right, is equal to exterior angle is equal to x plus y, right? This is because of the exterior angle.
B, C, P, and Q are 4 points on the ground such that B, P, and C lie in a straight line. Okay, so this line here, they're all on a flat plane and they all lie in a straight line. AP is a vertical flagpole, AP, which is why there are right angles over here. It is vertical. The angle of elevation of A from Q, so from Q to A, there's an angle of X, while the angle of elevation of A from C is Y. Okay, so from C to A along the horizontal, the angle is Y. The length of PC is R, and AB is equal to AQ as indicated on the diagram. So firstly, it says show that AQ, which is this side along here, is equal to R multiplied by tan of Y, all divided by sine of x. Okay, so when you get a question like this, what you need to do is obviously look for the side that you're dealing with, AQ. And then you need to try and find what else they're looking for. So obviously we have the angle y and the angle x. Now, if we see or look on our diagram, x sits over here and y sits over there. So that's in two separate triangles. So when you have two different triangles that involve a variable that you need to be working with, you need to try and find a side that relates those two triangles. So if I look here, in triangle APQ, which involves x, and triangle APC, which involves y, obviously side AP is common. Okay, so if I can find an expression for AP that relates y and x, I can bring these two together. So firstly, let's look in triangle APC. That is a horrendous color. I don't like red. Sorry, guys. In triangle APC, which is this triangle over here. AP, or well, not even, let's don't even start with AP. Do you see that we have a lovely right angle triangle? This here is a right angle. So the moment you see right angles, what do you think in trigonometry? Trig ratios. So we have this length here, which is the side adjacent to angle Y. And we're looking for an expression for AP, which is the side opposite to Y. So what ratio involves opposite and adjacent? Tan. So tan of Y is equal to opposite over adjacent is equal to AP divided by R, which is the adjacent side. So now, if we manipulate it to be in terms of AP, we can say that therefore AP is equal to R multiplied by tan of Y, because you multiply both sides by R and you get this expression. Okay, so that's in the first triangle. Now in the second triangle, which is this triangle APQ, we are looking for side AQ, which is this blue side. So that is the hypotenuse, remember? And we have an expression for AP, and AP is the side opposite angle X. So which ratio involves opposite and hypotenuse? Sine. So in triangle APQ, sine of x is equal to the opposite, which is AP, divided by the hypotenuse, which is AQ. Now we've got this expression for AP, and so we can substitute it in there at AP. So sine of x is equal to R multiplied by tan of Y over AQ. And now remember, we're trying to find an expression for AQ, so we need to get this equation in terms of AQ. So if we multiply both sides by AQ, we get that AQ is equal to, well, if I multiply by AQ on this side and divide by sine of x, I'm going to get that AQ is equal to R tan of Y divided by sine of x. And that is exactly what we needed to prove up here. Okay, easy peasy. Remember, if you have two different variables in two different triangles, find the side that they have in common and work with that. Okay. So now, secondly, it says, calculate the straight line distance between B and Q if angle QPC is 120 degrees and PQ is 30 meters. So QPC is this angle here, and that is 120 degrees. And they said that PQ is equal to 32 meters. Okay, so now we're trying to find, they said find the straight line between B and Q, which is this line here. Okay, so now that is the line we are trying to find. How do we find this line? Well, I can see already that over here, BQ obviously forms part of this base triangle here, this triangle BPQ. And we've been given PQ. So now, because we don't have any other angles, we can say that this angle in here is 60 degrees because angle's on a straight line. So basically, we just have this triangle that looks like this, BQP. We know that that is 60 degrees, that is 32 meters, and we're trying to find this side here, this BQ. We don't have enough information to use the sine rule, but if we look here, remember we're given that these two sides are equal. So now, if they're joined by the same vertical line, if we look here, this diagram is getting very complicated, but we've got this little triangle here, AQP, and then we also have this triangle here, ABP. Those triangles would be exactly the same because they both have a right angle here. So we have the right angle. Their hypotenuses are equal in length. Okay, so we have the hypotenuse. And they have a common side, AP, which means that they have right angle hypotenuse side. And that is definitely an argument to say that triangle ABP is congruent to triangle AQP, which is that triangle there and this little triangle here. What I'm getting at by saying this is that therefore, because these two are congruent, remember the congruent sides of congruent triangles are congruent. That means that this baseline here, BP, is equal to that baseline there. This baseline here is equal to that line there, which means that this side is also 32 meters. Now we have enough information to use the cosine rule. Okay, so we're going to get that BQ squared is equal to 32 squared plus another 32 squared, remember the sum of the two sides squared, minus 2 times their product, multiplied by cos of their included angle, which was that 60 degrees that we found through angles on a straight line. Okay, and now it's just a case of plugging this into your calculator. So we're going to get 32 squared plus 32 squared minus 2 times 32 times another 32 times cos of 60. And that is going to give us 1024. But remember, that's BQ squared. So we need to square root it. And that is going to give us 32. So that means that BQ is 32 meters. I know I went through this question quite quickly, but hopefully you understood my argument of congruency between these triangles and how I got to PQ being equal to BP. Okay, so thank you to Biesel so much for that question. Lovely throw of trig in the middle of our probability day. We will be in touch with you about getting your TV. Remember guys, it's that easy. Just take a video of what you're having struggles with and we could feature it on the show and you could be chosen to win a great prize out of our selection.